Actually, let me get three. Alright, this is definitely a use of. But I'm not just gonna let u equal to negative 3x. I'm gonna let u equal the entire what?
10 minus
The
3.
entire denominator. And you probably can see what's gonna come out of it. It's gonna be a natural log, isn't it? Does everyone see that? Good. You can get a natural log out of this. Let me just go through the motions. I think eventually a lot of you will get to the point where you do all this in your head. That's impressive too. You're kind of like, you see the derivative, you know where it falls, and you can zoom into that. The derivative is negative 3. Step 1, step 2, constant came up, so I'm going to divide it. Negative 1/3 du equals dx. All right, go substitute. What's this become? U. What's this replacing?
1 dx.
The 1 dx goes out. You get negative 1/3 u. Negative 1/3 du. So you got a 1 times a negative 1/3 du. Well, that's looking all messy. Where can I put the negative 1/3? Out there, and I can just put the d right there. That looks way better. But do you notice it wasn't positive, it was negative, because the derivative of that 10 minus 3x, does everyone see that? It's not positive 3, it's negative 3. Sometimes on a test, students' eyes, they miss the negative. You know, they go, derivative of 10 minus 3x is 3. But there's a minus with it. So this is going to be a negative 1/3 natural log of
10 minus 3x plus c.
u. And then, alright, very good, I'm going to go resubstitute. I have to keep the bars though. 10 minus 3x. And we got it. Any question on that one? I used this problem last semester. This one, some people didn't get, so I'm gonna try it with you. All right? Okay, ready?
Mhm.
I used this one last semester. This is back in the spring. The most students got it, but it was one of those, I go, wow, a lot of people's missing. It came close today. E to the 1 over x cubed. X to the 4th. Evaluate the indefinite. Okay. Is this a use sub? Well, let's give it a shot.
Okay.
But you know, it's like, don't worry if we try something that doesn't work. There's nothing wrong with that. I mean, maybe I should let u equal to x to the 4th.
Yep.
Because the derivative of x to the 4th becomes 4x cubed,
Mhm.
right? But that's not going to give us anywhere, is it?
No, let's do 1x cubed.
There you go, you're onto it. So you might think, well, hey, I'll let u equal x 4, and you go, that's not going to go anywhere though. You'll get your 4x cubed, but I'm trying to get that thing out.
Mhm.
So you're telling me, no, let it be the exponent, which was the what?
1 over x cubed.
And write it the way I heard it. What's another way to say that?
Negative
So I'm going to write it that way. When they're saying let u equal x to a negative 3.
3.
That's what it's saying. Get this over with. They're saying let u be, there's your 1 over x cubed. Right in that x to negative 3? So when you differentiate that, it's very good. Now it's derivative, so ready?
Uh-huh.
Negative 3 in front, decrease it by one. -3 on a number line, decreased by one.
One,
-4.
4, yep.
But I'm with you, Cal, because we're doing antiderivatives,
Yeah.
and we're jumping off to the side, and we're doing differentiation. You bet it can get confusing. You're like, which way am I going? That's why we do these errors. Like, so over here we're going derivative, and you're telling me that, right? Isn't that the derivative? Because we're not integrating over here, we're taking derivative. Differentiating this, -3 in front, decreased by 1, -3 goes down to a -4. dx. So step 1, step 2, now, step 3, I got that constant. I went du over what?
3,
-3
negative.
equals. Now, are you okay if I write it this way? X to a -4. What's another way to write that? 1 over x to the 4th dx. So take this and substitute for that 1 over x to the 4th dx. Put your u up there, you're gonna have it. Kind of weird though, huh? But it was because of the negative exponent. And we didn't see that, it wasn't obvious. So did you come up with that? It was a great idea. Oh, who was it? Coming with a negative exponent, that's the idea. We're not thinking that way with this one. It was hard to see how this thing would work out. We're like, well, that's x to a -4th, I mean, that's x to the 4th, but think of this as x to the -3rd power. Differentiate, it's gonna knock the x to the 4th out. We can get all you now, here we go. Come on in. Bye. du over -1/3 of that. What replaces this? Just a,
U,
so let me write this again. You got a -1/3 e to a u. I mean, couldn't have been easier. Either go e to u is e to u, right? Got it. Now, resubstitute, what would that be?
-1/3 e to the power x.
What was it?
minus
Whatever
3.
what? Whatever x cubed?
Mhm.
X to -3? Hey, after we do about 5 of these, I always like to stop and go back and do a definite integral. So when you all have that copy, I'm gonna pick 2 numbers. Obviously, I can't use 0 because what would happen here? 1 over what? So I can't use 0 up there. I can't use 0 up there. What would happen? Improper integral. So I'll just use 1 and 2. Alright, so here's the problem. Beck, would you try this? Just like every 5 problems or so, I like to stop and go, alright, do a definite integral. Oh, you're the best. That's e to the 1 over x cubed. Let me make sure I copied everything right there, Josephine. E to the 1 over x cubed over x to the 4th dx. Now when I change these to u's, these are now not x's anymore. What are these?
U,
U's. Now if you want, you can wait all the way to the end. You don't need the plus c, right? And right here, you can put what 2 numbers?
2 and 1.
Yeah. Right?
Mhm.
If you want to change these, go ahead, but you're going to have to use this.
So that will be 1 and 1/8, right?
There you go. And feel free to do that. You're going to find that way easier.
That's easier.
See, he does. He finds that way easier. Anybody proves that. If you're like, I'll wait till the end, all right, let's see what I get. -1/3 e to the 1 over, everyone, what's 2 cubed? 8. Subtraction, it's always subtraction. -1/3 e to the 1 over 1, which is what?
E to the 1.
E. There you go, but I'd make that minus a what?
Common and e to the power 1/8 plus e.
Is that okay with that?
Yeah.
Yeah? I know a lot of your copies. Is that okay I make that a plus?
Mhm.
Yeah? Does anybody like the factor?
1/3.
Alright.
you have to take the negative, okay, we want to do E minus, okay. E minus
Oh,
e to the power 1/8.
there you go. That's probably how it looks on like TI Inspire. TI Inspire does these, they'll find these antiderivatives, indefinite intervals. We get to do definite intervals. They'll just put it in, that's exact form. That's the exact area. I mean, this stuff deals with area, doesn't it? Area? Diet there. Okay, we're gonna see something now. You go, I've got U subs. Nothing can be stopped me. It's like, we got another one for you. Something we haven't seen before. So I hope it doesn't scare you, but I hope you kind of find it, hope you find it fun. I mean, we've pretty much seen everything. Natural logs, e's, we've done all the trig functions. We dealt with arctan, and we didn't need it. You split up the fraction just in that one, that was great, that was tough. So we've kind of seen everything. Well, this is number 67 out of the book. I'm gonna make it an indefinite interval. All right, even though the book made it definite. But it's number 67, everyone, it's in 5.5, it's on page 414. But I'm telling you, we haven't seen something like this before, this is gonna look bizarre. I think I did a problem yesterday, I had like x to the fourth, but then I had an x cubed. Or I had an integral and I had x, e to the x squared, right? A lot of times the power difference was the difference by how much? 1, right? Did you notice that? That's the idea, when you do the u sub, you do the derivative knocks that power down by 1, right? And that's what makes these things work. Well, look at this problem. Before I do, before I put the next one, I want to roll that. And what did we let u equal to? X squared, and we were able to knock that x out. That was the idea. We got it all changed and used it, worked fine. Well, we haven't seen anything like this, but we'll make it work. Because look at the powers. Aren't they the same?
Mm-hmm.
So it's like, you might not even think substitution rule because of this. Wait a minute,
No.
that's x to the first.
Half,
And that's x to the what?
have 1.
First, right? Usually it's x squared, and then we take the derivative, we get u equal, like, usually this is x squared minus 1. We let u equal x squared minus 1, and the derivative of x squared minus 1 is 2x, right? And then what happened? And then we're able to knock that x out. So this is a bizarre scenario, isn't it? Okay, a problem that would have been a lot easier than this, maybe, because we haven't seen this before, would have been this. And when you would have knocked this out in no time. In fact, I think we'll do this afterwards. I'll let you compare it and say which one you think is easier. This one, you would fly to, because you'd let u equal x squared minus 1, the derivative is what, 2x?
Mm-hmm.
We get this x to what? Go away, who cares, we get a fraction, it's a constant front, right? This is kind of bizarre to us, we haven't seen this yet, because we're saying this is weird how this is x to the first and this is what? X to the first. Well, let's try something. Let's see if we can get to work. Let's try to use something. Maybe we can make it work. Because we got no other option right now. And it's in this section, so somehow it's gotta have to work. Any suggestions on what to let u equal to?
X minus 1.
I'm gonna try it. Okay. U equals x minus 1, alright. Well, it looks like I'm only doing 2 steps, everyone. There's not gonna be a third step, because what's the derivative?
Dx.
There's a 1 here, right?
Mm-hmm.
I'll put it like 1 dx, it's a dx. But this we couldn't integrate. But if we take this and we go in there, we just kind of maneuver it, we manipulate it, we're gonna make it so we can make it work. Let's try it, ready?
Mm-hmm.
I know it's looking like, this doesn't look like we can do this one. We'll get it. First of all, I can change dx to what?
Du.
Okay, great. That didn't help much, did it? Okay, what can I put in place of this x minus 1? Oh, it's looking better. Yeah?
Mm-hmm.
So now you got that. But right now I'm still like this. I'm all upset. I'm crying. is not working, what's still left over?
X.
X. And let me put the original problem down. Someone in this class is gonna come up with an idea for it. Because it's just not working. Don't erase anything, we're onto it. It's just, I'm getting all upset. I did everything and, ugh, see? I guess I should give up. Let's not give up. Do you have an idea for it? Do you?
Could you get rid of the square root?
Nope.
Is that,
But we can somehow change X and put it in terms of U.
We're a product, right? So change it in terms of U plus one.
You got it. All right, very good. Did anybody else see this? Did anybody else see this? Claire, you see it? It's like, I'm so upset because this goofy X is still here. It's not working. Daggone it. But we're like, man, if I could just get this in terms of what letter? U, right? That's what we want. In the U cell, we're trying to get all this in terms of U. That's what this means in terms of U. This daggone thing's still sitting here, right? But we went over here and you go, hold up. Can we rewrite this thing right here? I'll just draw an arrow. What would X be equal to in that expression? If U equals X minus 1, then what's X equal to? That means X equals, you bet. We let U equal X minus, look at that fraud. So now what can I put in terms of X? It's the only time we ever did this. We went back to this, solved for X to see what we couldn't put in place of that. So what can I put in place of this guy?
U plus one.
And now we're gonna go to the problem. I'm gonna put a parentheses around that. And I'm gonna put a parentheses around it because there's a square root of U next to it. Let me rewrite this. Oh, this is half face now. We got it now. That's the idea. But you got how many of those? And that's why that was buried at the end of the textbook. He had this buried way near the end one like this. Because you don't get these too often. How many of these do I get in my Calc 2 and Calc 3 courses? Practically none of these. I don't see these often. Seriously.
No, but if you
I have a
do
problem.
integration by product, then you can do it, right?
You could try it.
Okay.
You could try it, but